They were designed and built and operated. One was in Morgantown, West Virginia, which was the site of a government ammonia plant, which we built for the government. And the second one was twice as big as the first one, and that was going into the Alabama Ordnance Works in Childersburg, Alabama, which I had worked on in 1941. And the third one was going into the Wabash River Ordnance Works. It was going to be 3 times bigger than the first one. And that was the plant that I worked in 1943. So we got these up. As we were designing these, and one of the reasons we thought the government was looking at heavy water, that is one way to moderate neutrons in a nuclear power. And one of the thoughts was that Germany had invaded Norway to get their heavy water plant. Because Norway had a heavy water plant there that they made by the electrolysis, the electrolysis of water. That's how they did theirs. A lot of electricity there in Norway. So while we were working on this, the commandos, the British commandos, I believe, helped by the Canadian commandos, went into that plant, sneaked into that plant at nighttime, and destroyed a good part of it. In other words, it was to sabotage the plant. Well, next morning on the radio and on the paper, they told us all about this. Well, we got up and sort of danced around in the office because this was going to help us get ahead of the Germans. And I've finished that with good senior engineers. I'm working on it. And then they transferred me to what they call the separations area. Now we're going to work on taking the slugs from the uranium slugs, which have been irradiated in the piles, reactors, if you want to call them that, also known as piles. And we were going to take these irradiated slugs, and they were coming over to the separations area, and that's where we get the plutonium out of the 30+ other radioactive materials that have been created from this uranium. And those other 30 radioactive materials is going to be waste, and that is the current waste. That is a terrible problem at the plant, at the Manhattan Project plant in Hanford, Washington today. There's an enormous project there now, which is going to concentrate that waste from over 100 underground tanks. These tanks are 750,000 gallons each, concrete enclosed, and the plant is underway at the Hanford Engineer Works today to glassify that, pump it out, concentrate it, enclose it in glass, glassify it, then enclose that glassed cylinder into a stainless steel cylinder, and it would be heading to Yucca Flats, Nevada. If you can ever get Nevada pleased enough with acceptance, but that's all designed to be headed that way. And this is going on now and will be going on for the next 10 years. So anyway, I'm now in the separations area, and it's my job there to work with these engineers. We're designing the equipment that's going to be used to do this separation. It was a water process, and what you do is you precipitate and then centrifuge. We had big solid bowl centrifuges, as I recall, in one of these separations buildings, of 40 cells each. Each cell contained within a building, these cells within the building. Each one of these would contain a tank and a centrifuge. Centrifuges was a solid bowl centrifuge, just like a washing machine, only the bowl was solid, and it would have a 30 horsepower motor on it to turn it. All this, as I recall, we had 11 steps, centrifuging and precipitating steps in each 221 building, and we had 3 of these buildings. And the first step, these slugs would come over in what we call a cast car. It was a big lead cast mounted on a railroad flat car. and it would leave the reactor area. First thing it would do from the reactors, they would push us and to get these slugs out of the pile and push them into stainless steel buckets. And these buckets would then be cooled for 30 days in a reservoir, underwater reservoir. All this had to be done remotely too because it was hot. Then they would take these stainless steel containers full of slugs, uranium slugs, which are enclosed in an aluminum enclosure. And these would come over to the 200 area in a cask car, on a railroad cask car. We would have 2 or 3 flat cars between the cask car and the locomotive. And he would come across the desert 3 or 4 miles to get from a reactor plant to the 221 building. We had 3 of those. And he would go along, 5 or 10 miles an hour. But in case he had a derailment and a lid of the big lead cast, this cast had over 10 inches of lead thick walls. And if they ever had a derailment and they spilled these things out, at least the engineer would be 2 or 3 car lengths away. Obviously, at 10 or 15 miles an hour, you're not likely to have a derailment. I don't think they ever did. These would come over to the 221 building, and he would back this car into the 221 building, which is now 221 building, 800 feet long. You have 40 cells in there. You have an overhead crane traveling the entire distance here, and he's going to unload these. He's going to drop the car in this place, and they're going to close the canyon door, and then the crane will come along, overhead crane come along to lift the lid off of the cask car, and take these vessels, these stainless steel cans, if you want to call them, full of slugs, and unload them. Then the first step you would have in the 221 building is you would remotely, it's all done remotely. They'd take this can, one of these canfuls of things, but the size of a garbage can, but they're all made out of 2512 CB, not 18.8 CB, but 2512 CB. And they're going to be processed in equipment all the way through this canyon. Everything is 2512 CB. All the pipe, tanks, centrifuges, all, not 18.8, but 2512. And so these cans would be upended into the first step, which was called a dissolver. And then from, we dissolve the aluminum can, or the enclosure off, and that would go to the waste tanks. And now you have aluminum by process of dissolving and precipitating, centrifuging, and repeating that, I think it's 11 times in a 221 building. You finally get down to the point where you have pretty good plutonium. I mean, pretty pure plutonium. And what we did, we would end up with plutonium nitrate. It was, at the end, a very, very syrupy, thick, somewhat solution. And that is what got shipped to Los Alamos. When they got it, they would reduce it to plutonium metal and create a bomb from it. So now getting back to
did you know what the end result was going to be?
We knew it was going to be a bomb. We had some reason to believe that Los Alamos had something to do with this, but because we had people that would visit Los Alamos. Now, they would not come back and tell us what they were doing, but we're almost sure that a bomb is going to be a result of what we were doing. The fact that Los Alamos actually did the bomb, I was never aware of that, but I knew they had something to do with the project. But get back to the 221 building, the overhead crane we had, as I recall, was made by Whiting, W-H-I-T-I-N-G, and it ran the entire length of the canyon over these 40 cells, and the cab of the crane was behind a a concrete wall. Obviously, the concrete wall couldn't come. The cab tended to be overhung behind this wall. The wall ran the entire existence of the canyon, and the cab was was encased in lead. In other words, we had heavy lead outside of all. The penetration of radioactivity from the canyon could not get to the operator in the cab of this crane. The crane is the nerve center and everything of this entire building. If anything happens to that crane, you're not going to process anything, because the minute you introduce radioactive stuff into the dissolver and get on with the process, the canyon becomes radioactively hot and is inaccessible by man. So here we have the Whiting crane, and underneath the two crane beams spanning the canyon, there are two submarine-type telescopes. These telescopes connected electrically. I believe they called it a Selson, S-C-L-S-Y-N, electrical connection, so they always ran together. And they could run back and forth across the canyon. The eyepieces were in the cab. He could rotate the eyepieces on the other end, telescoped in over the canyon, so that he had depth perception, because we had a telescope under the beam, two beams that make the crane that the crane is constructed from. So now he can look down into the canyon 40 feet below and see everything that he has to do. Now, on one cable is an electrically operated impact wrench, and that wrench will fit over the hexagon top stud of what we called a pipe connector. We call them jumpers because we had pipe jumpers conducting liquids from tank to tank and from cell to cell. And we also had electrical jumpers because we had electrical motors, as I mentioned before, 30 horsepower centrifuge motor. And we had, in order to maintain maintenance in this place, if anything went wrong, they would use the crane, and we had, with the impact wrench, they would be able to unloose all the connectors, electrical and piping, lay them aside. They could remove the tank, take it down to cell, I think, with 40 cells in here, and I think 37, 38, and 39 or 40, they were called junk cells. And if you had bad equipment or some sprunkle leak, you could take this out and throw it in the backyard. You take it to one of these junk cells and put it in there, and then you would come through another, what we call a mock-up building, and we had mock-up cell in that building, which exactly duplicated the cell outline and pipe connections and electrical connections that we had in the canyon. And you would put a new tank or new centrifuge, go through the mock-up building with all the connectors, and then you would move that, just like you with a train, into the tunnel of the 221 building, and just like you unload the containers of slugs, you would unload the tank, the jumpers, and with the overhead crane, with the telescope and the impact wrench, he would install these all remotely, and you'd get the thing back into operation, because you could not go into the canyon with a man to do this. But in other words, if anything happened to that crane, the canyon would be dead. And what happened, we had the crane, we worked with the crane manufacturer on this, and the main cables we had installed when it came off the drum, there was a big hydraulic knife device that if you had the crane doing some of this work down in the canyon, and some way, somehow, the hook got hung up on something, and you could not move the crane, this building would be out of service. So through this hydraulic knife, you could cut the cable remotely from the cab, and at least that would release the crane, and he could come down to the unloading area where we unloaded the slugs and closed a door, that big vertical closing door, and there maintenance people could go in and put a new cable and hook on that.
Oh, okay. So you
Whether that ever had to be done or not, I don't know. But
so you could decontaminate the crane. I mean, when you moved it into the other building and shut the door for the canyon.
at least what you could do is I'm sure they could try to decontaminate it. But one thing that you can do you can have limited access of human beings. In other words, a human being can stand so much radiation, but you don't want to give him too much. So by the rotation of a number of people, you could go in and make the necessary repairs.
Okay.
Whether they ever had to do that or not, I'm not aware of them having to do that ever. But the facility was there for doing it. None of these facilities are working anymore anyhow. The plant is completely shut down.
Oh, it is?
Yes. The only thing that they're doing at the Hanford Engineer Works today is working on the disposal of the waste. And the 105B reactor, which is the one that went into production first, it is on the verge of becoming a national monument. Whether they will ever make a national monument out of the separation area is not known at the present time.
Have you been back out there?
I've been out there. I was a guest of Westinghouse. GE, let's get back to Dupont. Dupont vacated this place in, I think it was August of 1946. It was the latter part of 1946 at Dupont, who said at the very beginning they did not want to keep on operating this plant. They got out of it there and turned it over to GE.